Alrighty. So we get to keep playing with our little functions and our graphs, and today we're going to look at some linear functions and their slope. So you guys have heard this 110 times, haven't you? So for 1.4 we have linear functions and slopes. So today we're going to make sure we know how to find slopes and what the definition of slope is for when it comes to linear functions. We're going to make sure we know how to take a point and a slope and make it into an equation in maybe like the point slope form or the slope intercept form. And then we'll also talk about like the standard form when it comes to equations, or when it comes to linear functions, linear equations, and how we can find like x and y intercepts and graph them and all that good stuff, right? So hopefully it's a good chunk of it's kind of review, a little bit of a refresher, and keep on going, right? All right, so if we're talking about linear functions, we want to know how to get from one point to the next. So we look at that famous thing of the slope. And we know that slope is ultimately the change in y over the change in x. Some of you guys refer to it as rise over run. And then you guys always ask me, well, what's rise over run? If you're rising, you're going up or down, so that's going to be your y. And if you're running, that's going to be your x. And now some of you guys have taken some fancy math or science classes. And have you guys ever seen the little delta y over delta x? Do you remember seeing that? I think physical science and physics, I think you guys get into it, right? Maybe? Yep. And then you're like, what's all this craziness? Well, when you figured out that change in y over change in x, or that delta y over delta x, you were ultimately just figuring out like what the slope is of what it was you were trying to compute, right? There's 4 different types of slopes. We could have a positive slope. Oh my. What's causing all that? Right. So on a positive slope, if you get your x and y coordinate plane, so just like in English, we read from left to right. So for it to be a positive slope, our line would look something like this, right? So as we were traveling along and we got to our line, we actually go up, right? So that would be a positive slope. If it's not positive, it could be negative. Yeah. I was hoping to fit all 3 or 4 across. I don't think I'm going to. Yeah. If I'm a negative slope, I'm a boo-hooer. No. Something like this would be an example of a negative slope, right? Reading from left to right, as I get to my line, I'm going down, 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 burning, ring of fire. So that would be a negative slope. Oh, well, I guess we're just going to go the next. Well, I'll fit it on there. Stay. Another possibility would be a 0 slope. So we have my little x and y coordinate plane. And so on a 0 slope, it would be I'd have an incline or a decline of 0, so it would look like a nice, flat, straight, horizontal line. Because is there a change in my y? Nope, I'm staying flat, right? I'm not going up or down, I'm going straight across, so there's no change in my y. So it'd be 0 over, well, my change in x can be whatever, because 0 divided by anything is going to be 0. And then last but not least would be a undefined slope. So I get my cute little xy coordinate plane. And if I have a perfectly straight vertical line, that would be undefined. Because mathematically, when it comes to looking at an undefined slope, remember it's change in y over the change in x. So when I look at my y values, are my y values changing? Yeah. So let's say I wanted to get to this point to this point. Well, how much am I changing? I don't know. Let's say 2, right? So the change in y would be 2, but when it comes to my change in my x, am I going left or right at all? No, so my change in x would be 0. So then I'd have like a slope would equal like 2 over 0. And can I divide by 0? No, I can't have 2 rotten apples in my bucket of 0 apples, right? So it's undefined. We can't define it because there's no change in the x. Right? Where on this one, if we thought of our slope, our change in y, so when I go across here, am I going up or down any? Nope. So my change in y is 0. But my change in x, if I wanted to go to this point, right, for poops and giggles, how far is that? I don't know, 3? It would be 3. Can we have 0 rotten apples in our bucket of 3? Yeah, we just don't have any of them, right? So that would be a slope of 0. Remember all those good guys? Right. So if I gave you 2 points, could you find the slope? So if I said find the slope of a line, because we're doing lines, you know, and they're going to pass through a point that pass through the points. Let's go with -3, 4, and just to keep it spicy, 2 and -5. So we know this is the x coordinate, this is the y coordinate. And then on the second point, this is the x coordinate and this is the y coordinate. So mathematically, what does the word change mean? If I go to the store and I buy a soda that cost $1 and I gave the cashier $5, what's my change going to be? $4, right? How do you come up with the change of being $4? You did 5 minus 1, right? So anytime you see like that word change, oh well, I guess it's in here. Change means the difference, which is subtracting. So if I want to figure out my change in y and my change of x, I gotta subtract my y's. And it doesn't matter which one you start with. You can start with the first point or the second point. Anybody got a preference? Second one, yep. So the second one, my y value is -5, and then I'm going to subtract 4. And then since I started with my second point, then for my y, when it comes to my x, I just have to start with that same point. So I got to start with that second point. So then I'd have what? Oop. 2 minus a -3. What are we going to get? -9 over 5? Did you guys get that one? All right, time to wake you up. How about you guys try one? How about a little you try? How about finding the slope between 4, -2 and 4, 3? What's my slope gonna equal? You guys agree with me? Disagree? Oh, throwing rulers around now. Ha, I overthrew the ruler. Alrighty. You guys good with slope? All coming back to you? Alright. So let's talk about those 3 little forms when it comes to being able to write those equations of lines. So let's start with point slope form. Oop, if I can get this little thing to stop moving. So if I'm writing it in point slope form, I bet you I'm going to need, or they're going to give me a point, and I'm either going to need or they're going to give me the slope. So we write the point slope form as, y minus y1 equals mx minus x1. What do you think m stands for? Slope. Yep. And then this x1, y1, guess what that is? It's a point, right? Like technically this x and y is a point as well, but when they want us to write it in point slope form, they want us to find the slope, and then they want us to find one very specific point to put into our equation that way. So if we wanted to I guess we'll write the equation of a line. Here, I'll get even specific for you. That passes through the point. Never knew there were so many words, did you? Let's go with 1, 5, and has a slope of 2. I can fit it in there. So in point slope form, we need a point. Do we have a point? Yep, right there. And we need a slope. We got the slope. We got one right there. So if I fill in my equation, right, y minus y1 equals m x minus x1. This x and y is going to stay in the equation, right, because that's for any and all of the points on the line. So we got to fill in the rest of it. So what are we going to come up with? y minus, what do we want to put in for y1? 5, yeah, equals, our slope is 2 x minus x1, and what's our x1? 1. And then if you wanted to get really super fancy, you could then turn this into slope-intercept form, right? Because slope-intercept form is just where you have y all by itself. So we're just going to use our distributive property to get the 2 through everything, and then we just got to add the 5 over. So we'd have, we'll do it over here, right? So y minus 5 equal 2x minus 2. Add the 5 over, y equals 2x plus 3. Slope should be the same, right? Still should be 2. And then where's my y-intercept? At 3. Right. And both of them are the equation to that line. It's just 2 different forms, right? Let's say they wanted you guys to come up with the equation in point slope form, but they gave you 2 points. And let's say they say that it passes through like 4, -3, and -2, 6. So if I want to put it into point slope form, I need to know a point and I need to know the slope. Do I know some points? Yep, and I can use either one of those points, but what do I need to find? I need to find the slope, right? So to find my slope, change in y over the change in x. So if I go to subtract my y's, -3 minus 6 is going to give me a -9. 4 minus a -2 is going to give me a +8. 6. Sorry, my bad. Yep, 6. And then we can reduce that one down, right, to what? -3/2. So now I have my slope, and then now I have a point. And you can pick whichever point you want. Right? So if we picked the first point, you would just have y plus 3 equals -3/2 x minus 4. And if you went through and did the distributive property to put it into slope-intercept form, you'd have the same answer if you did it the other way. If we used this point, we would have what? Y minus 6 equals -3/2 x plus 2. Okay. So these 2 equations give you the equation to the exact same line. It's just this one is giving you the equation, okay, and they're talking about this point. This equation, they're just giving it to you where it is at this point. So it's on the same line, they're just telling you what it is here and what it is there. So you're going to get the same exact line. All right. So we got point slope form. Anybody know the other form? Another one? The most famous one of them all? Not Santa. No, it's Rudolph, right? Isn't Rudolph the most famous one of them all? Christmas is coming. All right. Slope-intercept form. We kind of just talked about slope-intercept form. Y equals mx plus b. M is the slope. B is the y-intercept. Yep. So if we take like our little problem, that last problem, where we found out that the slope was -3/2, okay, and it went through the point, oh, why is this thing jumping on me? I don't know, let's say 4, -3, okay? So on this one, if they give it to us this way, do we know the slope? Yep, they gave us the slope. Do we know what the y-intercept is? No, right? Because the y-intercept is where we cross the y-axis, and that would be when our x is 0. And on this point, our x isn't 0. So the easiest way I think it is to find it, you got two choices. You could put it into the point slope form, like we did up here, and then you can go through and solve it to where you get the y equals. Or the other thing you can do is this x and y is a point that's on the line, right? So do you know a point, an xy coordinate that's on the line? Yeah, you got this guy. And do you know the slope? That's that guy. So you have everything to fill in except for the b, and it'll give you the y-intercept, right? So for us, for our y, we would put in -3. Our slope is -3/2. Our x is 4 plus b, because we don't know what our b is. So we give it -3 equals -3/2 times 4. That's going to get us what? -6. Okay. Plus b. Add the 6 over. So we get 3 equals b. So now we know the slope and the y-intercept. So what do we get? Y equals -3/2 x plus 3. And you guys all know how to graph these, right? All right. One last one. So you got point slope form, slope intercept form, and last but not least is the one that's called general form. It's not in the military. It's not a general, not a private. So when it comes to the general form, it's just where they have everything on one side of the equation, or of the equal sign. So we would have like ax plus by plus c equals 0. So it's just your x, your y, and your constant term. They just put it all on one side. So for example, you would have like 3x plus 2y minus 4 equals 0. And if you were asked to graph this, it's just like in math on everything, you guys all have options. If you guys like slope-intercept form, you can work through this to get y all by itself, right? Get everything onto the other side. So you could, add 4 over, so you'd have 3x plus 2y equals 4. Then you would subtract the 3x over, so you'd have 2y equals -3x plus 4. And then you would divide by 2. Right? So y equals -3/2 x plus 2. Right? And then you know that it's going to cross at 2, and it's going to have a slope of -3 over 2. Right? That's one option. I wonder if I could make this smaller. I don't think so. equals 2. The other option you can do, we'll just do a little squiggly, is we can always figure out how many points do you need to make a line? 2, right? So any 2 points make a line. So if we can figure out 2 points, then we can graph those 2 points, connect them, and then we get a nice long line, right, that goes on forever. So a lot of times when they give it to me in general form and I need to graph it, I just like to find the x and y intercepts. So if I want to find the x-intercept is where I cross the x-axis. And I know that if I'm crossing the x-axis, my y value is always going to equal 0, right? So I can put 0 in for y into my equation, and then I can solve it for my x. So I'd have what? 3x plus 2 times 0 minus 4 equals 0. So what am I going to get? 3x minus 4 equals 0. Add the 4 over. Divide both sides by 3. And x equals 4/3. So I know that on my x-axis, I'm going to cross at 4/3. Right? This is going to give me the point 4/3, and my y was 0. And then after I figure out my y or x-intercept, I can figure out my y-intercept. Y-intercept is where I'm crossing the y-axis. And if I'm crossing the y-axis, I know that my x value is always going to equal 0. So I'm going to take my equation, and what am I going to do? I'm going to put 0 in for x. So I'd have 3 times 0 plus 2y minus 4 equals 0. 2y minus 4 equals 0. Add 4 to both sides. 2y equals 4. Divide both sides by 2. Y is going to equal 2. So my y-intercept, my x was 0, and my y was 2. So then I can plot those 2 points, and it'll be the same line. Yes, ma'am? Well, my y-intercept is 2, right? What was my y-intercept? 2. Right? Well, so let's plot them. So watch. Boop. 1, 2, 3, 4. 1, 2, 3, 4. It won't be absolutely perfect, but it's going to be pretty darn close, right? So if I just did my 2 points, I have 0, 2. So that little guy. And then 4/3, 1. So 4/3 is like 1 1/3. Okay. So it's that little point-ish right about there. Okay. Oh no, I didn't do that. So that would be from the left, right? Then if we look at our blue one, our y-intercept is 2. So we're at that same point. And then our slope is -3, 2. So 1, 2, 3, 1, 2. And then that would have been the 2 points you connected.